Hi, this is Jason with Liquid Instruments. This is the first video in a two-part series about how to define and measure a transfer function for the Moku PID controller using Python. Today we'll introduce the standalone PID controller instrument and walk through the necessary Python commands to configure it. Let me start by first showing you the PID controller block diagram using the Moku UI, so we can know what we're doing later. You can see that it has two inputs, which are fed into a control matrix. The outputs of the control matrix are then fed into two independent PID controllers, and each of these has their own respective output. Along the way, there are several places where the user can add DC offsets, limiters, and switches. You can also see that there are probe points, which allow you to visualize the signal at different points in the measurement chain using the embedded oscilloscope. Let's click on the PID block, where you can see the current transfer function as defined in frequency space. The proportional gain and saturation levels are all set in values of dB, and the crossover points are defined in units of hertz. You can click on these symbols to enable and disable them, and we can click and drag these numbers around and watch the function change accordingly. You'll also see error messages pop up if you try to set a value too high or too low. Now let's open a Python notebook and show you how to define this function using Python. If you're new to using Python to control Moku, we have a step-by-step written and video tutorial on how to set up the Python API, which is linked in the description. I'm going to skip over the bits where I connect and set up to the instrument, as these are covered in that tutorial. This script that I'm using will also be available from our GitHub. Now there are two commands that I'd like to teach you. The first one is by defining the total gain and the crossover frequencies, which is how we were just looking at it using the Moku UI. This is called set by frequency. You can see that the command has a few inputs, the first of which is the target channel, and then each of the 6 keyword arguments can be specified. As we said, the gain and saturation levels in units of dB, and the crossovers in units of hertz. If you'd prefer to set these PID parameters all by gain values, we also have a command for that called set by gain. This works the same way, except P, I, and D are all now in units of dB, while the saturation values are now in hertz. This can also be accessed through the Moku UI through the advanced mode of the PID controller. The last command, which is universal to all instruments, is summary. It returns a list of the settings for the instrument, including all of the current PID values, which is very helpful when you don't have the visual feedback of the UI. So the question now is, now that we've set this transfer function, how do we check to see if the transfer function is working as intended? In the next video, we're going to use the Moku Frequency Response Analyzer to check that. So we'll see you next time, and we'll go through that together. Thanks.